Hey guys, how's it going? Today we're going to continue graphing rational functions, and the functions today, these are general rational functions. Okay, so go ahead and copy down what you see so far, and I'll be with you in a sec. Okie dokie. So for the types we're going to do today, they're all going to be fractions. They're going to be rational functions. You have something over something, okay? So the function equals this over that, okay? Now in every single case, there will be three cases today, A, B, and C, okay? For every single case, your x-intercepts will always be the zeros of P of x, okay? They'll always be the zeros of the numerator, okay? And the vertical asymptotes, okay, they will always be the zeros of Q of x, the denominator. Every single time for each example I'm going to do. We're going to do three examples, A, B, and C. Okay, so this right here applies to each example that I'm about to do. Okay, all right, so let's dig into the first example. The first example, we're going to graph a function that's written like this, P of x over Q of x, okay, when the P of x is a smaller degree than the Q of x, okay? So when the P of x, the degree is less than Q of x, the degree of Q of x, we have a horizontal asymptote of y equals 0. All right, so let me just give you an example of what I mean. Here we go. We have 3x, f of x equals 3x over x squared minus 4. All right, so first thing we need to do is the x-intercepts, okay? So x-intercepts, and that is the zeros of P of x. So 3 of x, set it equal to 0, right? So 3 of x equals 0, right? So what is x equal? All right, so if 3 of x equals 0, then x equals 0. So my x-intercept is 0, okay? All right, and then my vertical asymptotes are going to be the zeros of Q of x. So we have vertical asymptotes, and that's going to be when Q of x is equal to 0. So x squared minus 4, right? So x squared minus 4 equals 0. So factor that. So we have this equals 0, and that's x plus 2 and x minus 2. All right, and so we get x equals negative 2 and x equals positive 2. Okay, so there's my vertical asymptotes. And finally, we have a horizontal asymptote, the horizontal asymptote, and that is always going to be y equals 0. In this case, when the degree of P of x is less than the degree of Q of x. Notice the degree here is 1, okay, and the degree here is 2. So this is less than this one. So the horizontal asymptote is always going to be y equals 0 in this case. All right, so now all we have to do is plot these things. So my x-intercept is 0. All right, so just go ahead and put an x-intercept right there on 0. Then we have a vertical asymptote at x equals negative 2. So 1, 2. Here's my vertical asymptote here. Okay, and then also a vertical asymptote of x equals positive 2, so that's right here. Okay, and then we also have a horizontal asymptote of y equals 0, so that's right here. So this guy right here. All right, perfect. So now we're set up. Here's what I'm going to have you guys do. It'll make it easier than last time, okay? Because now we need a t-chart, but I'm not going to have you do it all by hand. This is going to take too long, so let's just go ahead and turn your calculator on. Okay, I'm going to clear all this. Let me go to this guy here, clear that. All right, and I'm going to enter this function into my y equals button, okay? So I have 3x over x squared minus 4. What I'm going to do is put it in parentheses, so 3x, right? Okay, close parentheses. Then divided by, more parentheses, x squared minus 4. So x squared minus 4, close the parentheses. And now I'm just going to get the table. Okay, so watch this. Second table. All right, and here we go. I'm going to scroll up because I have two asymptotes. So I'm going to scroll this way until I see them both. See where it says error there? That's where my asymptotes are. So I'm going to make a t-chart that looks like this. All right, here's my t-chart. X and Y. I'm going to get 3 points on the left side of that asymptote that I drew up there. So -5, -4, and -3. So -5, -4, and -3. Okay. Then I'm going to get 3 points to the right of that asymptote. So -1. Oops, let me go this way. Oh, sorry about that. I didn't see my calculator was off the screen. Okay, so -1, 0, and 1. -1, 0, and 1. Okay. And I'll scroll down and get 3 more points to the right of that other asymptote, 3, 4, and 5. So 3, 4, and 5. And then I'll go ahead and fill in these points. So 0.7, 1, 1.8, -1, 0, 1. I'm just copying these straight off my calculator here. Okay, -1.8. -1 and -0.7. You'll notice that they're pretty symmetrical, okay? All right, so now all I have to do, okay, is plot these points. So -5, -0.7. So -5, 1, 2, 3, 4, 5, and -0.7, that's right here. Okay, -4, -1. Okay, so -4, 1, 2, 3, 4, -1. All right, and -3 and -1.8. So 1, 2, 3, 1.8 is right there. You'll notice it looks like it's going down. That's actually the curve. Remember the hyperbolas you did the other day? Okay, so we're going to curve that like this and then extend the line so that it hugs that asymptote. Okay, so it's going to look like that. All righty. And then let's graph these guys. -1, 1, 0, 0, just like predicted. Okay, we already knew that one. That was our x-intercept. And 1, -1, that's right here. And it looks like it's going like this, right? Okay. Keep in mind, though, it's got to curve up toward this guy. They're going to curve and get closer and closer. Okay, so it's going to look like this. All right, there's that guy. And finally, we have 3, 1.8. 1, 2, 3. 1.8 is right there. 4, 1 right there. And 5, 0.7. It's right there. And you can notice it's curving too. Okay. So I'll go ahead and draw that curve. And this guy here. So basically all we're doing is just drawing pretty pictures, connecting dots and stuff like that, okay? But the main thing that you guys need to know for this set of notes is that we always have these x-intercepts, we always have these vertical asymptotes, and when we're doing part A, we're going to have a horizontal asymptote of y = 0 when p of x is less than the degree of q of x. When the degree of p of x is less than the degree of q of x. Okay? All right, so now let's do part B. All right? Here's part B. All right, and that's going to be graph when p of x is equal to q of x, when the degree of p of x is equal to the degree of q of x. Okay? And when that happens, we get a horizontal asymptote, okay, of y equals the lead coefficient of p of x over the lead coefficient of q of x. All right, so this is the lead coefficient of p of x and the leading coefficient of q of x. That's going to be our horizontal asymptote. Okay, so let's do an example really quick. We have y equals, I'll do this one here, x squared minus 5 divided by x squared plus 1. This one might be a weird one. What do you guys notice? All right, let's find our x-intercepts, okay, our x-intercepts. All right, well remember that's the, see what I have here? The x-intercepts are always going to be the 0 of p of x. All right, so this is x squared minus 5 equals 0. So let's solve that. So we have x squared equals 5, okay? And so take the square root on both sides, plus or minus. X equals plus or minus. Now the square root of 5, I'm just going to do this real quick. Let me get out of here. Clear that. The square root of 5, that equals 2.2. Okay, so plus or minus 2.2. All right. And then we also have the vertical asymptote, and that is when q of x, okay, we're going to find the zeros of q of x. All right, so we're going to take this guy, x squared plus 1, set it equal to 0, okay, and subtract 1. I don't know if you guys can see what's going to happen here. What am I going to get? I'm going to get imaginary, right? So x equals plus or minus I. So this guy, no vertical asymptote, okay? And finally, the horizontal asymptote. Let's look back here. Oops, I wrote it right here, sorry. The horizontal asymptote is going to be the leading coefficient of p of x over the leading coefficient of q of x. So the leading coefficient here is 1 over 1. So the horizontal asymptote is y equals 1 over 1, which equals 1. Okay, so let's go ahead and graph that guy. All right, so we have an x-intercept of plus or minus 2.2. All right, so x-intercept of 2.2 right here and negative 2.2 right there. Okay, all right, we do not have a vertical asymptote and we do have a horizontal asymptote of 1. Okay, so let's go ahead and put a horizontal asymptote of 1 right here. All right, and now all we have to do, okay, so we've set everything up that we want. Now all we have to do is take our calculator, okay, and just get some points really quick. So let's go back here, clear out whatever you have in there, okay, and I'm going to just enter this how I see it. All right, so I have parentheses, x squared minus 5, so x squared minus 5, close the parentheses, divided by x squared plus 1, so parentheses, x squared plus 1, close the parentheses, and now I'll just show my table real quick. Okay, so here's my table. All right, x and y, and I'm just going to go from like negative 6, that's 0.8, negative 5. I'm going to go all the way to 6, okay? So 0.7, negative 4, oops, sorry. Forgot you can't see that there. Negative 4, 0.6, negative 3, 0.4, negative 2, what is this? Negative 0.2, negative 1, negative 2, 0, negative 5. Scroll down here. 1 is negative 2. 2 is negative 0.2, 3 is 0.4, 4 is 0.6, and 5 is 0.7. Okay, I'll just go there. Okie dokie. All right, so there's my t-chart, and now let's just plot those points. Okay. All right, so here we go. I have, let me get it here. I'm going to go with negative 5.7. So 1, 2, 3, 4, 5. 0.7 is right here. Okay. Negative 4 is 0.6 right here. Negative 3 is 0.4. Okay. Negative 2 is negative 0.2. So that dips below here. See that? See that curve there? Okay. Negative 1 is negative 2. Okay, let's see, 0 is negative 5, so 1, 2, 3, 4, 5, and then it starts to go back up, doesn't it? 1 and negative 2, let's hear, aha, look at that, and let's see, 2 and negative 0.2, and then it's looking really symmetrical like this, so I could pretty much predict how it's going to go. It looks like that, and now just fill this in. Okay, and draw your picture. And that is all my time, guys. I'm out of 15 minutes. I'll be right back, okay? So there's my picture. I love you guys. Talk to you soon.